Welcome to Dr. Yap Van Ha's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. The problem today is about a 4-digit number. But we do not know what the number is. The digits in the number, they are represented by letters. Different letters represent different digits. This number, when multiplied by 9, the product is this number. The question is, what are the digits in the number? What digit does the letter L stands for? What digit does the letter I stands for? What digit does the letter V stands for? And what digit does the letter E stands for? Let's try. Have you managed to find out what digits the 4 letters stand for? Or maybe you're halfway through solving the problem. Let's see. We have a 4-digit number. When we multiply that by 9, we have a product, which is also a 4-digit number. What do you notice about the number and the product? You are right. The digits reverse, isn't it? Which of the letters you can tell what it stands for? Can you say something definite about the letter L? Notice that when we multiply the 4-digit number by 9, the product is still a 4-digit number. What must the letter L be? Can it be 5? Will 5,000 something multiplied by 9 give us a 4-digit product? It's too big, isn't it? Can it be 4? Can this be 4,000 something? Would 4,000 something multiplied by 9 give us a 4-digit product? It's still too big, isn't it? Can you decide what digit does the letter L represents? And if we know what digit this is, can we conclude what does E stand for? We know the 9 times table, isn't it? In the 9 times table, do you notice something about the products? In particular, the digit in the ones place? The products in the 9 times table include 9, 18, 27, 36, and so on. Do you notice something about the digits in the ones place? So if we know what this is, can we conclude for sure what that is? And once we know what the letter E and the letter L stands for, Can we figure out the letter I? What must it be? And then afterwards, the letter V. Why don't you give it a go before we look at the answer? What are the answers? Letter L has to be 1 or 0. Because even if this is 2000 something, 2000 something multiplied by 9, the product is already a 5-digit number. So the letter L has to be less than 2, which means it's either 1 or 0. But we knew that this is a 4-digit number, and a 4-digit number, we cannot have 0. Otherwise, it will be not a 4-digit number. So we know that the letter L has to be the digit 1. So we know that it has to be 1. And if the number we have is 1000 something, letter L being 1, and we multiply that by 9, we end up with a product. And the ones digit is 1. Do we know anything else about the other letters? Letter E. Think about the 9 times table. There's only one possibility in a 9 times table to give you a product that ends with 1. Which multiplication in a 9 times table ends with a 1? 9 times 9 equals to 81. But is that the only one? 8 times 9? 7 times 9? Oh, they don't end with 1, isn't it? In those, they end with 2, 72, and 3, 63. Is it true? The only multiplication in the 9 times table where the product ends with a 1 is only 9 times 9? So we are certain that E has to be 9. Which kind of makes sense because 1000 something multiplied by 9, you end up with 9000 something. Kind of makes sense as well. So we now know that the letter E is 9. 2 more letters for us to solve. In multiplying the ones, 81, we need to rename. Do we rename when we multiply the hundreds? We don't. That is why we end up with 9 in a thousands place. So what digit can the letter I be? It cannot be 2 because with 2 in a hundreds place, when we multiply by 9, we end up with having to rename and then adding to the 1000 we will not get the 9,000. So I has to be less than 2, which means it's either 0 or 1. It cannot be 1 because 1 is already used for L. And the problem did say that different letters stand for different digits. So now we know the letter I is 0, which leaves us with only one more letter to solve. I wonder, what digit does the letter V stands for? So we know multiplying the ones gave us 81. And then we know that multiplying the tens, we will end up with a 0 in that position. 9 times what plus 8 would give us an answer that ends with a 0. I think you are right. There's only one possibility for the answer to be a multiple of 10, ending with a 0. That's an 8, isn't it? We can check. 9 times 8, that's 72. 72 and 8, that's 80. Giving us a 0 in a tens place. And with the renaming, does it give us what it should be? You can always check whether our solution is correct with the letter V being 8. If our solution is correct, when we multiply 1089 by 9, we should end up with 9,801. If you find today's problem easy, you can challenge yourself by solving this other problem. 1 together with 2 together with another 2 together with 3 and another 3. What's the sum? As usual, different digits are represented by different letters. The same letter represents the same digit. And here we have another puzzle where we have 5 numbers, a 3-digit number, a 3-digit number, a 3-digit number, a 5-digit number, and the same 5-digit number. When we add them up, 1, 2, 2, 3, and 3 give us 11. Our problem is this. Different letters stand for different digits. The same letter stands for the same digit. find out what digit does each letter stands for. Remember, the letters in front, they cannot be 0. Otherwise, ONE will not be a 3-digit number. How interesting. Do you notice that we have many different letters? How many different letters are there in this puzzle? We have 9 different letters, and there are only 10 digits. In other words, in this puzzle, all the digits are used except for 1. I wonder which digit is not used in this puzzle. Anyway, if you find today's problem easy, here's a puzzle for you to try. See you next time in another problem box.
I can't forget the day we met. Your eyes so blue, me piercing through. I can't forget the day we met. Your smile so bright.